Okay. For the quiz on Thursday, a couple things. There will be no more than 10 questions. 3 of them will come straight from your homework. So from page 126, 1 through 11, there'll be one problem. There'll be a problem from 126, 18 through 26, and then one problem from the bonus assignment on 127 for 30 through 41. So we're going to look at a couple of these today real quick. On the first one, we're going to use substitution. The only time to use substitution is if you have a variable that is already by itself. So in this case, we have y that's already completely by itself, and we know what it equals. It equals 3x. So what we're going to use substitution for is in the second equation, we're going to rewrite it. But where y is, we're going to put a parentheses 3x. We're going to substitute the 3x in for y in that equation. From here, all you're going to do is solve for x. And so we're going to multiply 3 times 3x, which is 9x. Okay. The next step is to combine your like terms. So 4x plus 9x is equal to 13x. Okay. And then solving for x, I need to divide both sides by 13, and I get x is equal to 2. Okay. A lot of us stopped at this point when we were working on our homework. And so the problem is you only have half of the answer. So what we need to do now is we take the value we just found for x, and we go back to the original equation and we plug it in to solve for y. So we're going to rewrite that first equation, y equals 3, but where x is, we're going to put times 2 because that's what x is. X is equal to 2, so we're replacing the x with the 2. And so we multiply 3 times 2 and we get 6. So the answers is you have x is equal to 2 and y is equal to 6. Okay. And in a system of equations, we're always going to write our answers as an ordered pair. And the ordered pair always goes in alphabetical order. So the x in this case comes before the y. So it's parentheses with the 2 comma 6. And that is the solution. Okay. For the quiz tomorrow, or Thursday, if you write this and you don't actually put the if you don't put this on here and you just leave it with y is equal to 6 and x is equal to 2, but you forget to write the ordered pair, that is going to cost you a point. Each problem is going to be 4 points, and so this here is going to be worth 1 point. So if you don't put that, you're going to lose that point. Okay. Second thing is if you write it like this with just 2, 6 without the parentheses, okay, that's not going to be an ordered pair. And so what we'll end up doing here is you're going to lose a half of a point if you just write it like this. Okay, it needs to have the parentheses around it. Okay. Also, at this point, you should know how to. You should know your alphabet. If nothing else, you can sing it in your head. But these go in alphabetical order. So if you flip-flop it around and put 6 comma 2 instead, you will lose that same point that you get for putting it in parentheses. So as long as all your other work is correct, you can still get 3 of your 4 points. If you choose not to show any work, so all of this and this is necessary. Okay, if all you put is the answer, if all you put is the 2 comma 6, you'll get 1 of your 4 points and you won't get any of the rest of it. You have to show your work. Alright, so to do substitution, the substitution method, you have to have a variable completely solved for already, so all by itself. So in this one, we have t that is solved for. Okay, t is equal to 2r plus 3. So what we're going to do is rewrite the second equation, but where t is, we're going to put a parentheses with 2r plus 3. So we're just rewriting this equation, but where that t is, we're going to replace with what t is equal to. Next step is to get rid of the parentheses. So we're going to take that negative 4 and distribute it to the 2r and to the 3. So I'm going to bring down my 5r. Negative 4 times 2r is negative 8r. Negative 4 times 3 is a negative 12. And just bring down my equals 6. next step is we can combine like terms. Negative 5r minus 8r is negative 3r. Bring down the minus 12 equals 6. And to get the r by itself, I'm going to get rid of the minus 12 by adding it. And then lastly, I will divide both sides by negative 3. So r equals negative 6. And I said lastly for solving for r. Okay, so just like on the previous one now, I need to find what t is. So I'm going to take that negative 6 and plug it back in for r in that first equation. So t equals 2 times negative 6 plus 3. So t equals negative 12 plus 3. So t equals negative 9. Okay. And so again, r comes before t in the alphabet. So when I write my ordered pair, the negative 6 is going to come before the negative 9. Alright. So the other method, when we don't have a variable that's already solved for, so in this case, none of the variables are by themselves. The x's both have 4's within them, and the y's have a 9 and a 6, and so none of the variables are by themselves. So when you have that, you're going to use elimination. And for elimination, you need to have one of your variables needs to have additive inverses as the coefficients. So if one of them is a positive, the other one needs to be a negative, but they need to be the same. They need to be the same number. So in our problem, we have the same number on the x's. We have 4x in the first one and 4x in the second one. But like I just said, we need to make one of them needs to be a negative. So what we do is we multiply one of them by a negative 1, and you multiply the entire equation by that. So negative 1 times 4x is negative 4x. Okay. Negative 1 times 6y is a negative 6y. Negative 1 times negative 2 is a positive 2. Okay, so when you distribute a negative 1, all it does is change the sign on every term. Okay. And so now I have a positive 4x and a negative 4x. So I'm going to add my two equations together, this equation and this equation. So 4x minus 4x is 0. 9y minus 6y is 3y. And then 1 plus 2 is 3. And that's a real simple solution right here. Divide both sides by 3 and y equals 1. Now again, same process. I take my solution that I have, y equals 1, and I'm going to plug it back into one of the equations, one of the original equations, where y is. So we'll just put it in that first one. We have 4x plus 9 times 1, because that's what y is, equals 1. And now I'm just going to go through the process of solving this. So 4x, 9 times 1 is 9. Okay, subtract 9 from both sides, and I have 4x equals negative 8. And then divide both sides by 4, and I get x equals negative 2. So again, negative 2 comes before, x comes before y in the alphabet. So in my ordered pair, the negative 2 comes before the 1. So that's that one. All right. So that takes us through the 18 through 26. When you have the same coefficient already on one of the variables, or opposites in that case, in some cases. But every once in a while, you have a problem where neither one of the variables has the same or opposite coefficients, and so you need to get one of them the same. All right. So in this equation, what we're going to do is we're going to work to eliminate the x. You can choose whichever one you want. The same process applies. So, but this is what we're going to work with, is we're going to eliminate the x. And so to do that, we're going to multiply both equations by a number. And the number we're going to multiply by is the opposite coefficient from the other equation. So that top equation, I'm going to multiply by the 5 that's from the coefficient on x in the bottom equation. And then I'm going to flip that in the bottom equation. Instead of multiplying by 5, I'm going to multiply by 3. Okay? And so, since that's the coefficient on the x in the top equation. And the only other issue is I want one of them to be negative, and since they both started out as positive 3x and positive 5x, I need to multiply one of my equations by a negative. So I'll multiply that second one by a negative 3 instead. Okay. Alright, so when I multiply by 5, on that top equation, 5 times 3x is 15x, 5 times 7y is 35y, and 5 times 15 is 75. On the bottom equation, negative 3 times 5x is negative 15x, negative 3 times 2y is negative 6y, and negative 3 times negative 4 is a positive 12. At this point, I have opposite coefficients on the x term, so I can add these together, and that will eliminate the x. 15x minus 15x is 0, so they cancel out. 35y minus 6y is 29y, and then 75 plus 12 is 87. To get y by itself, I divide both sides by 29, and I get y equals 3. Just like every other time, I'm going to go back and plug that value for y into one of the equations. So where y is, I'm putting times 3. And from here, I'm just going to solve for x. So 5x plus 6 equals negative 4, because 2 times 3 is 6. Subtract 6 from both sides. 5x equals negative 10. Divide both sides by 5. X equals negative 2. So my ordered pair is negative 2, 3. Okay. On our graphing that we did earlier in the year, a couple weeks ago, 2 or 3 weeks, Thanksgiving, we would graph two equations and would normally get something like this one here, where the two lines intersected, and we looked for that point of intersection right here in the middle. Okay? And so when that happens, you actually, the solution will be an ordered pair like we've been doing, x comma y. Okay? But there were two other kinds of lines. Sometimes we had parallel lines, and when we had parallel lines, there was always no solution. And then sometimes we would have the same line, and when we had the same line, it was an infinite number of solutions. So when we graph these, that's pretty easy to see. But what does it look like when we solve these with algebra? And here's the way we do that. If I work this problem the same way I just did the other one, I'm going to multiply this row by 4 and this row by negative 2. And through that, that'll get rid of the x term. That's what I'm focusing on here. So when I multiply that out, 4 times 2x is 8x. 4 times 5y is 20y. 4 times 12 is 48. In the bottom, negative 2 times 4x is negative 8x. Negative 2 times 10y is negative 20y. And negative 2 times 6 is negative 12. So when I add those together, 8x minus 8x is 0. 20 minus 20, or 20y minus 20y is 0. And then 48 minus 12 is 36. So we end up with the equation that says 0 equals 36. So what happened is we eliminated both variables instead of just one. When you eliminate both variables, your answer is either going to be no solution or an infinite number of solutions. Okay? And it's going to be based off of what the 0 is equal to. Okay? If the 0 is equal to some number other than 0, in other words, it's a false statement, you're going to have no solution. So this problem that we just did, the solution is that there is no solution, because those are parallel lines. Okay? If instead you would have ended up with 0 plus 0 equals 0, that would have been a true solution, a true statement, and that would have given us this infinite number of solutions, because those would have been the same line. Okay, so your assignment on page 127, 30 through 41, you're going to have a few of those kinds of problems. Okay, and so that means it's also a possibility of seeing one or two of those on the test on Thursday. Now that is the setup. There was one problem that I skipped, but you work it the same way you did the one previous before that, so it's not a big deal. During class time on Wednesday, if you need help with the bonus or any of these problems, please ask, and we will be glad to help you out.